Welcome to the lesson on autonomous vehicles. Let us look at the lesson objectives. By the end of this lesson, you will be able to explain what autonomous vehicles are and how they are different from traditional vehicles. You will learn about the different levels of driving automation. You will also identify the key technologies that make autonomous driving possible. In addition, you will understand some of the major challenges that affect the widespread adoption of autonomous vehicles. Finally, you will examine the current state of autonomous driving technology and explore how it may develop in the future. Let's begin by imagining a future where cars can drive themselves. Think about riding in a car that can safely drive without someone controlling the steering wheel or pedals. These vehicles are called autonomous vehicles, or self-driving cars. They use sensors, computers, and advanced software to understand what is happening around them and decide how to move safely on the road. Instead of relying completely on a human driver, the vehicle can detect traffic, pedestrians, and road signs on its own. Some modern cars already include features that help drivers, while future vehicles may be able to handle the entire driving task. Now that we understand what autonomous vehicles are, let's look at how driving responsibility gradually shifts from humans to machines. Autonomous driving is classified into different levels of automation, from level 0 to level 5. Look at the image on the right side. The table shows who is responsible for driving at each level. At the lower levels, the human driver controls most of the vehicle functions, while the system only provides assistance. As the levels increase, the vehicle begins to handle more tasks like steering, braking, and acceleration. Now look at the image on the left. It visually shows the transition from human driver control to full machine control. At level 0, the driver does everything, while at level 5, the passenger simply rides and the car drives itself completely. To reach these higher levels of automation, vehicles need several advanced technologies working together. The first important technology we will look at is how autonomous vehicles see the world around them. Self-driving vehicles use several types of sensors to detect objects and understand their surroundings. Cameras identify road lanes, traffic lights, and signs. Radar sensors measure the distance and speed of nearby vehicles. Ultrasonic sensors detect objects very close to the car, such as when parking. Another powerful sensor called LiDAR uses laser pulses to create a detailed 3D map of the environment. The vehicle combines information from all of these sensors to build a complete picture of what is happening around it. Even with powerful sensors, autonomous vehicles also rely on very detailed maps. Self-driving cars use high-definition maps, which are much more precise than the maps on a typical navigation system. These maps contain detailed information about road lanes, intersections, curves, and traffic signs. The vehicle compares the map with what its sensors detect in real time. This helps the car determine its exact location and plan safe routes. These maps are updated regularly through wireless software updates to keep information accurate. Now that the vehicle can see the road, it must also understand what it is seeing. This is where artificial intelligence, or AI, becomes important. AI allows the vehicle's computer to analyze large amounts of data and recognize patterns. For example, AI helps the car identify pedestrians, other vehicles, bicycles, and traffic signals. It also helps the system understand complex driving situations, such as busy intersections or merging traffic. In many ways, AI acts like the vehicle's digital brain, helping it interpret information and decide how to respond. Artificial intelligence becomes even more powerful when it learns from experience. Self-driving systems use a technique called machine learning. Engineers train these systems using millions of driving examples collected from simulations and real-world driving data. Over time, the system learns how to recognize different environments and predict how other drivers might behave. This allows autonomous vehicles to improve their performance and decision-making abilities as they gather more data. Now that we understand how autonomous vehicles sense and interpret their surroundings, the next step is understanding how the vehicle actually controls its movement. Autonomous vehicles use electronic systems known as drive-by-wire controls. Instead of relying entirely on mechanical connections, these systems use sensors and computers to control steering, acceleration, and braking. Sensors detect commands, computers process the information, and electronic actuators perform the action. This system allows faster responses and more precise control, which is important for automated driving systems. Now take a look at the diagram on the right side of the slide. It compares two different steering systems. On the left side of the diagram, you see a traditional steering system. When the driver turns the steering wheel, the motion travels through a mechanical shaft and gears to turn the front wheels. On the right side of the diagram, you see a steer-by-wire system. In this system, sensors detect the steering input, a computer processes the signal, and electric motors turn the wheels. There is no direct mechanical connection between the steering wheel and the wheels. This electronic control is what allows autonomous systems to safely steer, accelerate, and brake the vehicle. Autonomous vehicles also benefit from communicating with other vehicles and systems. Modern vehicles can connect to communication networks that allow them to share information. This includes vehicle-to-vehicle communication, where cars exchange safety warnings with each other. Vehicles can also connect to cellular networks to access real-time data such as traffic updates. Short-range communication technologies allow nearby vehicles to coordinate their movements. These connections help create a smarter and safer transportation system. With all these technologies working together, autonomous vehicles offer several important benefits. One major benefit is improved safety because vehicles can detect hazards and react quickly. Autonomous vehicles may also improve mobility for elderly or disabled individuals who may not be able to drive. Smoother acceleration and better coordination between vehicles could reduce traffic congestion and lower fuel consumption. In addition, passengers may gain more free time during travel because they do not need to focus on driving. Let us now take a look at some of the challenges to the adoption of autonomous vehicles. Let's take a closer look at some of the main challenges. Autonomous vehicles must handle difficult driving situations such as heavy rain, snow, or bright sunlight, which can interfere with sensors. The advanced sensors and computing systems required for these vehicles can also be expensive. In addition, governments must develop laws and regulations that address safety and responsibility. Some people are still uncertain about trusting autonomous technology, and road infrastructure may need upgrades to support these systems. Because safety is critical, autonomous vehicles require extensive testing. Before being deployed widely, self-driving vehicles must undergo rigorous testing. Engineers use computer simulations to test millions of scenarios quickly. Vehicles are also tested on closed tracks and real roads under controlled conditions. These tests help developers identify problems and improve reliability. Billions of miles of testing may be needed to ensure the technology operates safely in many different situations. Another important challenge involves protecting vehicles from cyber threats. Because autonomous vehicles rely heavily on software and connectivity, they must be protected against hacking. Cybersecurity systems help prevent unauthorized access to critical vehicle controls such as steering, braking, or acceleration. Engineers use strong encryption, secure software updates, and protected communication systems to reduce these risks. Protecting vehicle systems is essential to ensure passenger safety and maintain public trust. Let us now take a look at the current and future trends in autonomous vehicles. Let's now look at some real-world examples of autonomous vehicle technology that are being developed today. Take a look at the first image on the left, which shows a robotaxi developed by Continental. This type of vehicle is designed to operate as an autonomous taxi service that can transport passengers without a human driver. The second image shows an all-electric robotaxi developed by Waymo, a company that started as Google's self-driving car project. Waymo currently operates limited robo-taxi services in some cities where passengers can request autonomous rides. The third image shows Tesla's autopilot system. Unlike robo-taxis, Tesla vehicles are still driven by humans, but they include advanced driver assistance features that can help with steering, acceleration, and braking under certain conditions. These examples show that autonomous driving technology is already being tested and used in different ways, although fully driverless vehicles are still being developed. Looking ahead, the future of autonomous vehicles continues to evolve. Over the next decade, autonomous technology is expected to improve significantly. Sensors will become more affordable and accurate, artificial intelligence systems will become more capable, and vehicles will become more connected to smart infrastructure. Robo-taxi services may expand in cities, and autonomous features may gradually appear in more consumer vehicles. Continued testing and development will help ensure that these systems operate safely. Let us now summarize what we have learned in this lesson. Autonomous vehicles are capable of sensing their surroundings and navigating with little or no human input. Different levels of automation describe how much control the vehicle has during driving. Technologies such as sensors, high-definition maps, artificial intelligence, and vehicle connectivity enable these capabilities. Although autonomous vehicles offer many potential benefits, challenges such as safety, cost, regulation, and cybersecurity must still be addressed. Ongoing research and development continue to move this technology closer to widespread use. Thank you for your attention.